real exam questions. This is question 21. It deals with slab design by means of yield lines. An hexagonal slab with a side of 5 meters, effective length, and thickness of 250 millimeters has a floor finish of 6 centimeters and is loaded with a mobile load of 5 kilonewton per square meter, characteristic value. The concrete cover is 30 millimeters and the slab is supported on all sides, simply supported on all sides. Determine the reinforcement for an average effective depth. Summarize your answers in a table. First, we look at the hexagonal slab with a side of 5 meters. We will look for the yield lines. So the axis of rotations are the supports on the 6 sides. There are 6 axes of rotation. Where the axis of rotation is crossing, then the yield line starts. And this way we got the yield lines. Just note that this is an equilateral triangle, so the distance from there to there is also 5 meters. The depth of the total depth of the slab was 250 millimeter, and the concrete covered 30 millimeter. The mobile load is 5 kilonewton per square meter, and the permanent load is of course the self-weight of the slab, which is 0.25 times 25, plus the floor finish gives you 7.63 kilonewton per square meter. Now we will calculate the design value in ULSP. This is 1.35 times the fixed load plus 1.5 times the mobile load to give you 17.80 kilonewton per square meter. The effective depth of the first layer of reinforcement is 250 thickness of the slab minus 30 the concrete cover, and we will assume that the reinforcement will have diameter 12. If not, we just redo the calculation the second time. This gives you 240 millimeter. D2, the second layer of reinforcement, the first layer is 12, so the second layer has an effective depth of 202 millimeters. The mean effective depth is 208 millimeters. The distance S is of course the length of this yield line multiplied by the cosinus of this angle, and this angle is of course 360 degrees divided by 6 divided by 2, so that's 30 degrees. So S is 5 times the cosinus of 30 degrees, which is 5 square root 3 over 2. The area of one such triangle is of course 8 times S over 2, and it will give you 10.825 square meters. We will use the unity of displacement as maximum displacement, so delta is 1. The work done by the external forces is then the total load on one triangle, which is the surface of the area, 10.825 times 17.80, which is the load, multiplied by the mean deflection, which is delta over 3. And we got that 6 times for each slab. So the total is 385.37 kilonewton meter. The work done by the internal forces is then equal to the yield line, like this yield line, projected directly through this axis of rotation, which gives you the length 5 times, of course, your plastic bending moment m, divided by the angle of rotation, which is delta over this distance s. And we got that 6 times. You have this once, 2, and so on. You got this 6 times. So D is equal to 600 6.928 m. E is equal to D, and from this we will calculate m, and m, the bending moment, the maximum bending moment is 55.625 kilonewton meter per meter. The needed reinforcement is the bending moment, to put in the right units, Newton and millimeter. So you multiply it by 10 to the power 6, divide by the lever arm, which is 0.9 times D, and divided by the yield strength of the reinforcement. And you add it 10% because we are working with the upper bound method. Gives you 755 square millimeters per meter. We use a diameter 12. And for a diameter 12, we need 6.6 bars per meter, or a diameter 12 center to center 150 will be okay, which is 755 square millimeter per meter. Now we'll put all the elements that we've calculated into a table. The effective depth was 208 millimeter, the mean effective depth. Total design load was 17.8 kilonewton per square meter. Work done by the external forces is 385 kilonewton meter. The work done by the internal forces is 6.9 kilonewton meter. And the maximum bending moment or plastic bending moment is 55.6 kilonewton meter per meter. And the reinforcement, the calculated reinforcement is 751 square millimeter per meter. And the applied reinforcement in the two directions is diameter 20, center to center 150 millimeter.